Welcome to this video. My name is DARSHAN KATGERI and I am working with Jain College of Engineering, Belgaum. In this video, we will be starting with development of lateral surfaces. What are the different methods of developing the surfaces? And again, we must take note that most of the solids, in fact, all the solids that we will be dealing with will be right regular solids. Means the axis is always going to be perpendicular to its base, and we are not going to develop solids or figures with oblique axis. That means the axis is not at 90 degrees to the base. So such things are not covered in these videos. So let us move on and see what exactly are the different methods and how we can develop these surfaces. First of all, we must understand we are only dealing with the development of lateral surfaces. Lateral surfaces means we are only dealing with the sides. Like for example, now here in this figure we have 4 sides. It's a square prism. There are 4 sides, and we will be developing only the lateral sides. Lateral sides means, like for example, the walls of the room. We are only going to deal with walls of the room, okay, of a particular solid. Or if we are considering any solid like a pentagonal prism, we are only going to consider the vertical surfaces, lateral surfaces, or slant triangular surfaces in case of pyramids, and we are going to develop only those things. That is, we are not going to uh, draw any development for the top surface and the bottom surface of this. That means we are only going to consider the sides, and we are going to develop this. So let us move on. Now there are two methods for development of simple solids. We have two methods. The first one is the parallel line development, and the second one is the radial line development. This parallel line development is used for prisms and cylinders. Prisms and cylinders. Now you can see that there are these lines. We're talking about these lines. There is one line here. There is one line here, here, and all of these lines, they are parallel to each other, right? Also in this case, which is a cylinder, you can see that all of these lines here, they are parallel to each other. So we call this as parallel line development, which is basically used for prisms. So this is an pentagonal prism here. Again, we see that we are using parallel line development, and this is a cylinder. Again, we see that here we have parallel lines, so we will develop this by using parallel line development. So this is one method, and the next one is the radial development. This is basically used in case of pyramids and cones. As shown here, we can see that there is this one point O, and all of these lines are drawn from that particular point, and from this point I can thus draw one circle, and on this circle I will mark all the important points. So you can see that these are like the radii of the circle. So all these lines are radii of this particular circle that I will be drawing. So this is called as a radial line development. So this is a square pyramid. This is a cone, wherein we have to actually calculate the angle here. But this introduction is concerned. Again, you see that you have this as the radius. This is also the radius. This is also the radius. All these lines are nothing but generators. I will be explaining all of this in detail in the subsequent videos. And then you see that we are for drawing this particular part of this circle, okay, and all these lines, they are like the radii of a circle. So we call this as radial line development. Oblique solids, that is the axis is inclined at some inclination. There are methods to develop such solids also. but those will not be developed, or those problems will not be solved in these particular videos. So there are two methods. The ultimate conclusion is right now we have to study parallel line development and radial development. Parallel line development is used for prisms, all kinds of prisms like square prism, rectangular prism, pentagonal prism, hexagonal prism, and cylinders. And radial line development is basically for pyramids and cones. So this is what we need to remember in this case. So let us move on and try to solve one particular problem, which is this problem. We are going to solve this problem. Let us read the problem. A square prism of base side 30 mm. So the side of the base is given. Axis length is 60 mm. So axis length is also given, and it is a square prism. So it is important, it is a square prism. It is resting on HP on one of its base with all vertical faces equally inclined to VP. This statement means that all of the vertical faces, they have to be at 45 degrees. So you can see that this face here is at 45 degrees with respect to the XY line. So you have to draw one 45 degree line, and on this line you should construct this particular square, which is very simple, and we have done such problems in projection of solids. The next thing is it is cut. Now you have to imagine or visualize that it is being cut by an inclined plane. So this is the representation of the plane wherein we are using a chain line, and the plane is at 60 degrees to HP. So you can see that the plane will be at 60 degrees. So this angle is 60 degrees. This angle is 60 degrees. The reference to this as the horizontal, and 60 degrees and perpendicular to VP. Almost in all the cases that we will be solving, the plane will be perpendicular to VP. So it is perpendicular to VP and passing through a point on the axis 50 mm, 50 mm from the base. It means that from this is the base of the prism. From here, the plane is passing through a distance or at a distance of 50 mm. So it is passing from this particular point, and actually we should be showing this dimension. This dimension is 50. Okay, 50 mm from the base. So from base you should mark 50 mm on the axis. So we know that the axis is exactly here. This is the axis, and so this line is in fact this edge, but behind that we have the axis. So they are one behind the other, so this point has to be considered. And draw the development of the lower portion of the prism. Lower portion means we should consider this portion here, this portion, all of this portion here, this portion here, and this portion will be removed and this will be retained. Okay. So let us get rid of all this ink here, and let us try to understand. So the first step that we have to do is that we have to draw the prism. We have to draw the prism, the top view of the prism and the front view of the prism. And let us do that in the software and see how to go about this thing. So now, even before going to the software, first we will do it in the software. That would be better. So I have opened the software, and let us do the sheet setup. So as usual, we are selecting A4 sheet and we are turning off the background and save default and say OK. And fit screen. Fit screen is this arrow marks which says fit. And quickly we will draw one square. I will take this square and I will give width. The width is 30 mm because the width is 30 mm, and height also will be 30 mm. And in this case I can give the angle. So if I am using this square command, I can give the angle. So I can straight away give 45 degrees and I will get this square. Once the square is drawn, I will name it. Let us name as it is given here. So this is ABCD, right? ABCD. So here we'll zoom in. This is A1. A1 is the base, in fact, and this will be B1. This point will be C1. Sorry. And this point will be D1. So this point is D1. So once we have done this, immediately we should dimension it so that everything will be correct. Okay. So now we are sure that this is 30 mm. This is square 30 mm. And after this, now we have to draw the front view. To draw the front view, I will draw one horizontal line, and then I will take the projections. I will change the thickness of this line, and from here I will draw the lines. So these lines will be drawn like this here. The thickness of this line also I have to change, so I will change the thickness of this line. Then again go to line command, change the thickness. I want 0.5 mm, and from this point to this point I will draw one line, and from this point to this point I will draw one line. Then axis, the axis is here. The axis is 60 millimeters. Axis is 60 millimeters. It is given here. So this line will be 60 millimeters, 60, and I will place it here. And then again I will take the inference from here, and I will draw this line. And again I will take the inference from here, and I will draw this line. And we will quickly name these things also. This is A dash. This point is A1 dash. This point is C dash. And this point is C1 dash. Okay. Then we have B dash and B1 dash here. And D dash and D1 dash. So this will be in bracket. This is a D dash and D1 dash. D1 dash, which has to be in bracket. So yes, it's like this. We can adjust these here. This is C1. This is A1, and these also can be adjusted. So adjust it properly. We have the axis here. Axis also is here only. The axis is O dash, O1 dash, O dash, and here we have O1 dash. Yes, the axis is also behind the edge, so I will also put this thing in bracket like this. Yes, now we have drawn the view and we have named it. Let us save this. We need this particular dimension. Yes. And then we can go ahead and name this as a vertical plane, and this as a horizontal plane, and this is X, and this is Y. So this is these are the things that you should be doing once you draw the view. Next, what we have to do is Yeah, it is equally inclined. Yes, it is at 45 degrees and it is cut by an inclined plane 60 degrees and perpendicular to VP, passing through the point at an axis 50 mm from the base. So what we will do now is, from this axis, from the base, I will draw one line. From this base I will draw one line and the length of this line will be 50 mm. So the line is drawn. I can't see the line, but if I just select this, you can see here, this is the line. And now from here I have to draw another line which will be at 60 degrees. 60 degrees, yes. So I will select one line and I will not limit the length, but I will constrain the angle. The angle is 60 degrees. So yes, this angle has to be 60 degrees. Notice that you don't know this point. We know only this particular point, and which is 50 mm away, right? So we have to draw it from this point only. Okay, we cannot draw it from this point because we don't know this point, right? So this point is known to us. It is 50 mm from the base. So that is why I have to draw it from this particular line, and it is at 60 degrees. It is at 60 degrees. Fine. So I will just draw this line and I will keep it like this. To represent this, I will make it a chain line. I will use extend to next command and I will extend this line here. And just for reference, I will draw one line and again I will use extend to next command and I will extend this line to here. Okay. So this can be imagined as the cutting plane. So now you can see that with respect to this particular line, which is the horizontal line, this line has to be at 60 degrees. So this has to be at 60 degrees. So you can see this. Okay. Actually, we have to thicken this on the extremities and show arrow. That is actual representation. But this for introductory course, this much is sufficient. So what we will do is we will select the lines and split these lines. I will split this line here and I will split this line here and I will split this line at this point. And I will zoom in and I will select all these lines, and let us change the thickness of these lines like this. Okay. And save this. So this part is going to be removed and this part is going to be retained. Now I will show you the visualization of what exactly is happening. So you can see that we have one square prism. We have a square prism. The square prism. So if I see the top view of this, it is appearing like this. It is at 45 degrees. So this line is at 45 degrees. Also this line here, this angle is 45 degrees. And now it is being cut. Means what? This plane that you can see, this particular plane, it is the cutting plane, and this is perpendicular to the vertical plane. So if you imagine one vertical plane, it is perpendicular to that, and it is at an angle to horizontal plane. So if we draw plane here, this is the horizontal plane, and if we draw one plane here, this is the vertical plane. So it's like this. Okay. So now you can see that this plane is 90 degrees with respect to the vertical plane, right? The angle, this particular angle it is going to make, it is at 90 degrees, and it is making an angle of 60 degrees with the horizontal plane, which is visible in the front view, like this, which is visible in the front view. So you can see this particular angle is 60 degrees, and this distance is given to us. So this point is 50 mm from the base. So this is the point that we are talking about, and this is the cutting plane. So you can see the representation, it has been showed with arrows and all, shown with arrows and all. So now what we have to do is, this prism has to be cut. Imagine that it is to be cut, right? So what we can do is activate this cut. After it is being cut, you can see that this is the profile that we get, and the above part is removed and the lower part is retained part. Okay. So this is what we should obtain, and if we are given a thin sheet or a piece of paper, how that sheet should be cut, so as when you fold this, when you fold it along these edges or creases, you have to get such a figure here. So what is the procedure of obtaining this, and that is what is development all about. Okay. So now what we will do is, now you can see that it is cutting, the cutting plane is cutting this square prism at 5 points. You can see this is point 1 here, point 2 is on edge B1. So if I deactivate the cut, I will just deactivate the cut, you can see that it is cutting at 5 points. So this is point 1, this is point 2, this is point 3. Point 3 is on the top face, that is on the edge BC. Point 4 is also on the top face, that is on edge CD. That is on edge CD, right? You can see this 3 and 4, and point 5 is on D dash. Point 5 is on D dash, and again point 1 is on A1. So you can see this. If I again activate this particular cut, we can visualize this in a much better way. So now we should mark these points on a sheet and try to obtain the development. Okay. So how to do this, we will see. It's very simple. Also, I am going to tell you one command. Before that, you observe that all of these vertical lines, they are parallel to the vertical plane, and in development we always require the true length. Remember, we always require the true length. It is very important that all of this has to be done on the true length. Okay. If true length is not available, it has to be obtained. The true length has to be obtained, and then the development has to be done. So this is very important, that all of the marking should be done on the true lengths. So in this case, all of these vertical lines are parallel to vertical plane. That is why all of them are in their true lengths. So we are going to make use of this particular information. So I will start by drawing a line. I will take this line and I will change the thickness of this, and I will draw one line at sufficient length. This length is not important, and I will draw one line from here, and I'm taking this projection. So what we have done is, we have gone this particular way like this, fine. So what is important to us is this particular line. So to obtain this line, we have drawn the projections. This line is A1. This is A, and this is A1. This is A1. Save it. Now I have to obtain all these lines, all these edges. I want B1, C1, D1, right? So A1, B1, C1, D1. So this length, or you can say the perimeter of the square, the perimeter of the square of 30 mm sides is 30 plus 30 plus 30 on back side and 30 on this side. So it is 120. So length from A1 to A1, from this particular length, it has to be 120 millimeters, and A1 to B1 has to be 30 because it has to represent this particular edge here, this particular edge. B1 to C1 is also 30 mm because it represents an edge which is 30 mm, and all the edges will be 30 mm because it is a square prism. Okay? If it was a rectangular prism, then this lengths would be different. Okay? But in this case, all of these lengths are equal. So we can make use of one command, and we can go to, you select this line first. This is important. If you just go to this particular mirror option, this arrow here, you will see that rectangular pattern and circular pattern are turned off. They will be activated only when I select this. You can activate this. Okay, so this is one command that I can use, rectangular pattern. However, I am going to show you this offset command, which is very easy to use. So you select this offset command, and now the distance that I want is 30 millimeters. So you give this distance as 30 millimeters, and you select this line, and you say OK to this. Just a minute. Okay. Select this line, go to this command. I want 30 millimeters. Say OK. Now I want on this side. This is some problem. Just give me 1 minute. So offset, I will cut this line. I will draw a fresh line from here to here. I just select this line, change the thickness. Now I will say offset. I will just redo this step once again. Yeah, for time being we can delete this, and yes, now it is working fine. Distance should be 30 mm. Okay, I will just repeat what I have done. I have gone to offset command. I have selected this line, and it is asking for this distance, and say OK. Then go on clicking. You will see that the line goes on appearing. You will get an arrow, and I want this is A1, BB1, CC1, DB1, and back to AA1. So I get these lines automatically. Finally, we can delete all of these at once. So you can delete these. You can select all of them and press the delete button. The delete button is not working on my laptop. So yes, obtain this. So you can see that this length is 120. This length is also 120. So you can select both of these and make it 0.5 and dimension this. This length is 120, as you can see here, and the distance between this and this is 30 mm. Okay. So all of these are 30 mm, and this point is point B, and this is B1. This is a C, and this is a C1. This is D, and this is D1. This is back to A and A1. This is important. It is not E, but it is same. We are going back to the same point, A, or same edge, A1 in that. So now we have obtained all of these. Let us save this. Now we will do the numbering for the points wherever the plane has cut this. Say like this. This is 1, this is 2, this is 3, 4, 5, and back to 1. So we have to do the numbering also. It is only for our convenience. Let us have this point as 1. This point is 2. Now there are 2 points here. We have to visualize this. If it is difficult, then what we can do is we have to draw one line starting from this point, and you just draw it till here. Now you will see that there are 2 points. There are 2 points here. So on this face there is 1 point, and on this edge there is 1 point, and on this edge there is 1 point. So there are 2 points. Again, important. So we will name 2 points here. We have point 3 and we have point 4. So we have 2 points here at this, and then of course you can say that point 4 is not visible and put it in bracket and all that, and this is point 5. Point 5 is behind. So like this, and back to point 1. So all of these points, they have to be now shifted in the sense projected onto their corresponding edges in this development. So we will draw this. Okay. Now we see that AA1, from here I have to draw one line. It cuts AA1 on this particular development. So that is point 1. That is point 1, right? So all that we can do is we can draw one line from here to here, and that will be the corresponding point. Okay. Similarly, we have to draw lines from B1. To get this point 2, you should draw one line from B1. This has been done because in 3D I have taken it back on the axis, and from there I have projected it. But in this view, you can do it directly. So I will just come to this view, and from this point 1 is on AA1. So I have to draw one horizontal line. This is point AA1. Then point 2 is on BB1. So this point 2 will be on BB1. So this has to be drawn here. Then to get this point 3 and 4, it is very important. We can't use this horizontal projector. So this projector that we want, now to get the lengths, we have to go to the top view. We should go to the top view. Okay. I want this particular distance from B to this particular distance. That is, in the top view, I want this particular distance. I want this distance, horizontal distance. Okay. And horizontal distance I want, right? Not the length of this, but I want the horizontal distance, this particular distance. So to obtain that, what we have to do is we have to go to the top view and measure this. So to measure, I will use smart dimension again. From this point to this point, again you will see this is the vertical distance, this is the horizontal distance, but I want the distance that is between these 2 points, the length of this line. So it cannot be obtained by this smart dimension. So what I will do is I will come out of the command and I will go to distance between this point here and this point here. Again it is giving me horizontal and vertical. For this, what I can do is I can go here to horizontal vertical, that is distance between, and say by 2 points. So in that case it will give me 8.16. So the distance is 8.16. This distance from point B is 8.16. Okay. Similarly, I need this distance also. Let us measure that distance also. It will also be the same distance, 8.16. So now you see that now this distance is being measured on from point D. So it has to be noted. So from B, this point is point 3. According to this, you can see the visualization. This point is point 3, right? So this is point 3. Point 3 is on BC. You can see point 3 is on BC. Point 3 is on BC. If we deactivate this one, we go here, and if we deactivate, point 3 is on BC. So this line is B and this is C, right? So let us come back here. Let me just zoom out a little bit. So from B, I should measure 8.16, this particular distance, that is 0.3. So let's come back here, and from B, I am going to draw one arc by center point, and this has to be 8.1. This distance has to be 8.16. This distance has to be 8.16, and I am going to draw one arc here. And this arc represents 0.3, which is the point on the top face. Similar procedure has to be done, but this time it is from point D, and see that this point 4, this is the point 4, is on CD. Point 4 is on CD. So you can see this point 4 is on CD. Okay. So now we have to plot this. From D, it is 8.16. From D, it is 8.16. So again, you should go to arc by center point, and from D, you should mark 8.16. 8.16. And you should mark the arc like this. Fine. And then 0.5. 0.5 can be directly obtained from this here. So again, from 5 I will take this, and from here I will mark this, and again 1. From 1 it is continuation of this line, so I will just draw it here. So once I obtain all the points, let us make this all of this very light first. Yes. Once we obtain all the points, then we have to merely go and join the points. So we have to join point 1. This is point 1. Then this is point 2. It is better that you name it as you mark it. This is point 3. Again, if you are not getting the correct this one, the correct intersection point, you can just go ahead and trim this off, because otherwise there are chances that we select the wrong point. So this point here, and from here again I want the intersection of this. Again, you can see I'm not getting the correct point, so again I will trim this off, and again I will use this line, and from this point to this point to this point and back to point 1. Okay, so this is we have to split this line, or else we can draw the lines here. 0.5. So this one here, and from this point here to here. We can split the lines and make them dark. That is also possible. And this is point 1. This is point 2. This is 3. This is point 4. This is point 5, and this is back to point 1. So we see that this is the development that is required. Of course, we have to show leader lines, and save this. This is the required development. This is the development. Okay. Yes. So if we see this front view, this is what it is, and now this portion, this particular portion, it has to be cut out, right? So if we cut a sheet like this, and if we fold it along these edges, we will get a solid which is like this, that is with this particular cap. So this is the theory of development. This is a simple problem that we have solved. This is the solution. This is the complete solution, in fact. And you have to keep on saving the files. So save it as .dft and .pdf, because PDF will be easy to take printouts. Yes, so this is the complete solution of this problem. This problem can be practiced on the grid sheets. Thank you.